Good morning, good afternoon everyone, and welcome to this series of tutorials on how to make a full web 3D runner game. In this first episode, I will introduce the game, we will set up our dev environment, and we'll even create a basic 3D scene with the Three.js package. Are you ready? Then let's dive in. Throughout this series of tutorials, I'll be showing you how I developed my latest game, Hyperspeed. This game is a 3D runner made entirely in JavaScript, HTML and CSS, where you control a spaceship that flies across an infinite grid. Your goal is to collect as many bonuses as possible, those are the little colored orbs, while avoiding the obstacles, those are the white cubes. Every time you get a bonus, your score increases. And every time you hit an obstacle, you lose a bit of hull integrity. When it reaches 0, your ship is destroyed, and it's game over. Infinite runners are direct descendants of arcade games. The whole point is that you are fighting a never-ending game and that you are essentially playing against yourself. But of course, from a programming standpoint, this implies that you need to continuously fill the level with new bonuses and new obstacles. So this series will be a good opportunity to talk about procedural generation, but also 3D programming in the web, event handling, audio management, and much more. Let's get started and set up our work environment for this project. I'll be using the VS Code editor, but you can use whichever IDE you prefer. But if you're using VS Code, something that is quite useful is a little package that you can add that is called Live Server. So if you just go to the extensions, you can get it, it's this icon here. And what this is able to do is create a development local server that hot reloads, so that every time you make a change, your web page just refreshes automatically. This is really cool for quick development iterations. So if you don't have it, just install it. And now we can just go ahead and create our basic index.html file. So let's create a new one here. And similarly, I also have some util snippets to automatically create bits of code like this. So this is a basic HTML page. And now I can just run this with the live server using F1 and here live server open with live server. So what this is going to do is just automatically open a web page that points to the right URL and that loads your HTML file. So now whenever I make a change on the left, it will automatically refresh on the right. So here, if I just add a new div with hello world in it, and I save my file, you see that it automatically refreshes and appears on the right. Now, something that I really like in terms of tree architecture for my web projects is to have my index at the root and then to have some subfolders for my styles in CSS and my scripts in JavaScript. So I'm just going to go ahead and create two new folders, one called styles and one called scripts. And in both those folders, I'm going to create a basic index.css file and a main.js script. Now I'm going to import those in the index.html file. So for this, I can just do a new link tag referring to my styles.index.css and a script tag to my scripts main.js. And so now I can just go ahead and add some styles in the CSS file. So for example, I can set I want my body to use sans serif font, and whenever I save my file, it just updates on the right. And similarly in my main.js, if I just add something to run on load, when my page loads, I want to alert hello. And when I save this, you see that I automatically get the alert whenever the page is ready. And I can click OK and I get my page. Okay, so this was just setting up a basic vanilla HTML, CSS and JS project. Now, what we want to do is to dive in directly and do some 3D using Three.js. Three.js is a JavaScript library that allows you to render 3D in the browser. You can do more or less complex scenes, and you can see here that you have a whole gallery of examples that show you the possibilities of this tool. It's really nice because it's not too hard to use, and it uses the WebGL renderer, so it's really fast and efficient. You can even do some PBR, so some physical-based rendering, material and shading stuff, if you want to get more realistic renders. Here we want to do something really simple. We'll just have our little ship and the grid and the orbs, so little spheres floating about, and basic blocky cubes. So we won't need all this shading stuff, but it's still interesting to note. I won't be diving into 3D too much in this tutorial, so if you're not familiar with it at all, you might be a little bit lost at the very beginning between what are meshes and materials and all that sort of stuff. Don't hesitate to check it out on the net. And if you want to learn more about Three.js itself, you can check out either the documentation that shows you the entire API and even a little getting started example that we'll be running through in this video, or you can also look directly at their examples. This is just a bunch of showcases to see the different options that the library has and what it provides you with. And so yeah, this is a nice way of quickly seeing all the possibilities of the library. Now, as explained in the doc, in the installation part, there are basically two ways that you can get Three.js into your project. You can either go through the npm repository, so that's if you're working in a node environment, or you can get it through CDN. The thing is that I myself had a big constraint on my production server, namely I couldn't run Node, so I just had to go with old plain PHP. And this means that I have to have a static project, and so I'll have to go with the CDN option. So this is a bit below on the page here. You can use the CDN or static hosting option. So what you can do to get this script is just type in something like Three.js CDN, and here you get the link to the CDN.js. So you can just go ahead and choose the Three.main.js. So as you can see, it's just a big JavaScript file that is quite unreadable. What I usually like to do is, rather than relying on the online version, so the one that is hosted on the CDN, I prefer to just download this file and to have it local in my project. This way I don't have any network issues, and if the CDN is down or if my own internet connection is a bit off, I don't have any slowdowns or complete inaccessibility. So the way I usually do this is just I copy everything and then I go to my project, and here I'm going to create another folder called vendors. This is a common term for third-party libraries. And so here I'm just going to create a new file called Three.min.js and copy everything in it. And I can now save this. And the nice thing is that I can import it just like my script's main.js. I basically have a new vendors Three.min.js. And so even if the internet is down, I won't have any access problems. I have my own local copy that I can refer to. So here I'm just going to add a new script tag to vendors/Three.main.js. And the question is, how do you actually use this slip? For that, we're going to go back to the Three.js doc, and we're going to go to the getting started, creating a scene example. Okay, so we'll be going through this tutorial together, and we'll just do everything in our main.js file for now. Later on, we'll decouple things and have a better organization of our functions, but this is just to show you the basics. So going through this tutorial, you see that the first thing you need to do is actually import Three.js. So that we've already done. And then you have to create the scene. So in Three.js, when you want to start working, you first need to create a 3D scene. Obviously, this is done using the scene object. So we're going to do the same here, and I'm going to say that we have a new scene. It is a new 3.scene. And then the next thing you want to do is actually have a camera in your scene. Remember, this is because we want to visualize a 3D scene in 2D. So this is just like a rear camera for photographs or cinema. Basically, you need to have some object that is able to get the 3D points and print them as a 2D image to show on your screen. So in this project, we're just going to go with the perspective camera. Don't worry too much about all the options. If you're interested, you can take a look at them. They're about the parameters and the properties of the camera itself. So namely the FOV, the aspect ratio, and the near and far clip planes. The aspect ratio, which is the second parameter, we'll talk a bit more in the last episode of this series. But for now, just copy back what's in the tutorial and it will work. And so the last thing you want to make is a renderer. So basically, this is the object that's going to be able to take the pixels from the camera and show them on your screen. So yeah, you just use the Three.js renderer object. Similarly, you have to set its size, and so here you have to use the size of your screen. So this is why we're using the window inner width and window inner height parameters. Those are to automatically get the current dimensions of your browser window. And finally, in the end, you want to append this new renderer as a DOM element, because what Three.js makes is actually a canvas, so an HTML canvas. And the camera is going to get info from the 3D scene, and the renderer is going to paint this 2D image on the canvas regularly enough for you to have this feeling of animation and 3D rendering. So just go ahead and copy the last line. And now if you save this and you go back to the scene, you see that we have our LOL from before and that we have just a big black screen. So it's actually a canvas. And this was created automatically by Three.js. So this is the renderer that we're going to paint things on. We're just going to go ahead and erase the LOL that we had before. And we're also going to take their advice, and in the index.css, we're going to say that the body has 0 margin, so that this block is just neatly stuck to the edge of the screen. So now our canvas covers the entire screen, and we're ready to actually add things to the scene and render them. So going back to the tutorial, if you scroll down a little, you see that this is where we're starting to add some geometry. So once again, geometry and meshes are basically the 3D objects that are going to be in the scene. And to give them some color, we're going to add some materials on them. So this is a common 3D pipeline. First you create objects with a given mesh, and then you just add a material in it to give it a proper color, some shininess, roughness, and other interesting visual properties. Okay, so back in the script. We want to create a box geometry. This is just a basic cube. This geometry is just a shape. It's not yet an object. We're going to see in just a second that the object is only when you call the mesh function. So for now we just have the shape of a cube and it hasn't been assigned to anything. But before we can create the cube, we also want to know what color it's going to be. So we're going to create a material. And inside here, you want to pass the color option. So this is the color for your object. And this color is written in hexadecimal code. So here we're going to say that the color is 0x00ff00. This is a green because the first couple of characters defines the red value. The second one defines the green value, and the last one defines the blue value. So this is the RGB values. Here we're just saying that we have a maximal value of F on the green and 0 on the other channels. So this is going to be pure green. And now we're ready to actually create the object. So this is done by using the mesh object of Three.js, by just passing in the geometry that we prepared and the material that we prepared. And finally, remember to add your object to your scene, otherwise it won't get rendered, because for now it's just floating around. It's created, but it's not assigned to the scene. And after line 13, it's actually added to the scene. So now we can see it. And the last line about the camera position is just to make sure that the object is actually in view. So we just place our camera at a given position on the Z-axis. So this is the depth axis. And so if we save this, you see that it's still dark. So what's happening? The thing is that for now, we aren't actually rendering. So we've prepared everything, but we haven't called our renderer. And so we haven't actually seen the scene, and we haven't transposed this image to our screen. So to do this, we need to call our renderer. So this is the next part in the tutorial. This is about rendering the scene. And the way it works is that you have to do a render, also called an animate loop. So you can't just render the scene once, otherwise you're going to get a still image with the initial setup, but if you happen to move your camera or move your objects, it won't get updated. To have it update, you need to have a little loop that just runs indefinitely and basically calls the same function over and over again, namely the function that renders the scene. And this is done using a JavaScript built-in method called the request animation frame that just uses the FPS, so the frame rate of your browser, and regularly calls your functions that it creates a loop that simulates continuity to the human eye. Also, something to note that is written here is that this request animation frame is called only when you're actually actively on your tab. So this means that our game won't be updating and calling lots of stuff if we're looking away, if we're on another tab, which is really great to save some processing power and some battery life on your device. Okay, so I'm just gonna copy and paste this function here. And so as you can see, the idea is that you define a function that is gonna call itself again regularly using this request animation frame we talked about. And every time it's called, it's gonna re-render the scene using the renderer, the scene and the camera. So this is basically a way of saying, get my 3D scene, pass it through the lens of my camera to get a 2D image, and shoot this 2D image on my screen using my renderer. And we have to call this function once at the very beginning to initialize the loop. And from that point on, it will call itself again and again, so we don't have to worry about it anymore. Okay, going back to our web page and saving this, we finally see a cube. So we have a green cube that's right in the center of the screen that is a bit away from us, because remember that we moved the camera back. And we have a basic 3D scene that's rendered before our eyes, so that's really cool. But 3D is about animation and movement. Otherwise, we could have just written some div with CSS and have a green square on the screen. So what we want to do now is add a little animation to this cube. We want it to have a little routine that updates its rotation and that makes it just rotates on itself around the origin point so that we can see it's an actual 3D object. So this is the last part of the tutorial. And as you can see, it's pretty easy. The idea is just that in our animate function, we want to add two new lines. We want to add some lines that change the rotation along the X and rotation along the Y axis of our cube. And we just add in a very little amount so that it looks smooth. Otherwise, if you put higher values, you'll just feel like the cube teleports to another rotation. So it's not as nice. So let's copy this and paste it in our animate function here. And so now if we go back to our web page and we save this, we see that the cube is moving around. Yay, it's rotating. So we've successfully made a little 3D scene using Three.js. We've seen that we have to initialize some objects to go from a 3D world to a 2D screen space. We've also seen that creating an object means first creating some geometry, so an abstract shape for the object to use, but also creating a material for the color, and that in the end you have to package all of this into a mesh that you add to your scene. And finally, we've seen that you have to use the animate function that is just called recursively over and over again to update the screen and optionally change some of the properties of your objects in the scene so that you have some animation. Okay, so we're now ready to start working on our own game, namely the Hyperspeed Web 3D Runner. And in the next episode, we're gonna start working on our game logic and create an actual game class to hold all of the parameters of our game. I hope you enjoyed this tutorial, and I see you soon in the rest of the series.